Hello, I'm Michael Morton from Solargy Australia. We're a registered R&D company in Australia, and I'm here to introduce the Solargy UltraGen, which is this device behind me here. This unit here, the UltraGen, which is this silver piece here, produces around about 10 times the amount of power of the best alternators globally. Sometimes people call them alternators, sometimes they call them generators. I tend to use the word generator, but more commonly they're known in the marketplace as an alternator. An alternator is just a mechanism for converting the kinetic energy, which is coming from this petrol engine here in this case, into electrical energy. And so the alternator does the job of doing that conversion, taking the kinetic energy, the rotational forces of the petrol engine and converting those into electricity. I do want to refer to this report where we actually sent this particular unit that's on the bench here to the US, where it was run up on a big machine about the size of a huge lathe, and it's put through its tests at all the different speeds, and they measure the output coming from the UltraGen, and that produces this graph here. That's the performance graph. And a little table at the top that tells us for each of the different speeds what the reading was, what the output was. So I'm going to pass this around just so you can have a quick look, and probably we don't need to go into a whole lot of detail except to say that the output from this particular alternator is particularly high for the package size. So we're not saying there aren't alternators that will produce 4.5 to 5 kilowatts. There are plenty of generators out there that do that, but they're a whole lot bigger, much bigger. A big alternator or generator is going to cost a lot to produce because there's a lot of materials going into it and it's heavy and there's transport costs and all of those costs will add up. This particular alternator uses not permanent magnets, which we tend to find in the Chinese models, but it uses an electrically excited magnet in order to get it going and start producing the amount of power. And because of its ability, because it is electrically excited, it means that we can basically turn off the load on this, so it puts no load on the motive source, or we can put a lot of load on, just depending on what we need. This box here is the controller that manages all of that. It's computer controlled. A lot of software design has gone into this, and the two can work hand in hand, or you can use them individually. So I'm going to hand over to Max now, and Max is going to talk a little bit about the advantages of this particular configuration over the typical wind turbine applications coming out of China, for example, using permanent magnets. So Max, the ball's in your court.
Yeah, thanks, Michael. I guess I'm thinking about eco-village applications, crystal waters where I'm living, where we're using a lot of solar at the moment. The advantage I can see in this case here is of course this petrol engine could be replaced by a wind generator, or people call windmill, a wind generator, which up till now has not been really possible because at the size which we can afford at a backyard scale, they can't really turn an alternator which would have these solar magnets, because the solar magnets are like a drag on. Whereas in this case here, of course the size is an advantage, a cost advantage, but in this case here what I see is as by having electrically excited magnets, as even at low wind speeds, it could start turning the alternator, and then once the speed is reached, once it has the momentum, then this unit would allow it to kick in and start to produce energy. So I see this of course being a wind generator, not a petrol engine, that's only for the testing. And then this being smaller, allowing the cost to come down as it's affordable by somebody who buys solar panels at the moment. And this being an important part of it, being able to control when this alternator would kick in, and that would kick in once the speed is picked up from the windmill.
Yeah. So can I ask you a couple of questions there, Max? So one is to get your feelings on the comparative cost of wind versus solar, and secondly, to maybe comment on the wind turbines that you might see beside the road or in wherever they happen to be. the reason why they just, invariably when you drive past them, they're just sitting there doing nothing, they're not turning.
Yeah, well, no, we've had solar panels before the GST came, so we had them for a long time. We paid a lot of money for ours, the ones we put in. And it wasn't really an economic decision, it was an ethical decision. But with the number of solar panels we see around the roofs around here now, it's obviously people make also a decision on their hip pocket. And I think these scientists could do the same thing to wind generators. As a wind generator is not just something people will put in their backyard because they want to tinker around with something, but they want to have an alternative to the wind, to the sun when the sun is not shining. So we have this combination option which we haven't got at the moment. And we haven't got it because the current alternators are too big, too expensive, and using solid magnets which are a drag, which are waste energy, which we haven't got in this area here anyway. We have very dirty wind in this area. It travels, wind travels over a lot of forests and houses and hills and valleys. So by the time it gets to crystal waters, a wind generator can't reach the speeds to be really viable at this point.
Yep, correct. Yep. So it's the infrastructure cost, picking up on the points that you've made, it's the infrastructure cost of building the wind turbine, which includes the cost of the generator,
Right.
together with the fact that the most common units, particularly coming out of China, there's a large number of wind turbines coming out of China, but they all use this permanent magnet design, which is using those super magnets that you might have seen in novelty shops and so forth. You can almost impossible to break magnets apart, they're so strong.
That's the drag. That's the drag.
That's the drag, yeah. So even when you've got a moderate wind, as I'm sure you'll confirm there, Max, you can have a maybe 6 to 12 kilometre an hour wind, but the wind turbine will just be sitting there perfectly still.
That's right.
So that's the issue that we're trying to overcome. We're trying to be able to harvest energy. This is an area of focus for Solargy. We're interested in energy harvesting, taking low levels of energy, wherever they might be, whether it be low-level sun, low-level wind, and producing much greater output. I've been to India recently, and I've been talking to them about wind turbine technology, and something that they stress to me, they constantly stress to me, is whilst India is a very big country, they have very small amount of grade 1 wind resources. Grade 1 is the sort of stuff where you put up those big $1 million wind turbines. A lot of their stuff is second tier, and it's also dirty wind, a lot of dirty wind, as Max calls it, or turbulent wind. And so you need a different type of wind turbine, and you certainly need your cost structure to be a lot lower. This is the perfect answer for a country like India, and potentially these things could be manufactured in the millions for that kind of application. So there's no shortage of application in wind turbines alone, and that's just the tip of the iceberg. Max, we were saying earlier that alternators can be used in a wide variety of other applications.
That's right. I mean, not only stationary, but also in mobile applications too. But no, talking about India, that application I'm thinking about, first world eco-villages, but I've just come back from Bangladesh. I mean, now half the population still hasn't got access to electricity. It's very, very basic things. We don't often think about it. For us, it offers an alternative to solar. And I think together with solar, a combination, a real alternative as a standalone system without huge batteries. It means we actually can have a standalone system, possibly with a battery pack, which is maybe even our car in the future. And it means we can get away from the grid. I've been dreaming about, but we never actually got quite there, and the unit here hopefully will get us there at the cost we can afford.